So we have to start today coordinate geometry. Concept of coordinate geometry, actually it is based on the Cartesian coordinate system. This is called Cartesian coordinate system. This is a horizontal line, vertical line. If these two lines are intersecting at a point O, then from this O point we used to have 0, and right hand side we will have 1, 2, 3 positive numbers on right hand side, and left hand side you will have negative numbers -1, -2, -3. Similarly, on the above of 0 we have positive numbers 1, 2, 3, 4, 5, like this. Here -4, -5. Similarly, below the origin we have negative numbers -1, -2, -3, -4, -5, and -6. Okay, here 4, 5, 6. This is the Cartesian coordinate system. And here this horizontal line x, O, x is called, this is called x-axis. X-axis. As you know, it is just recapitulation. You have already done these things, but here you will study more things. Y, O, Y dash, this vertical line called y-axis. Called y-axis. So these are two axes on which this whole coordinate system works. Okay, and they meet at the point O. Any O is called, we call the point O as origin. Point O called the origin. Okay. If we have any point P on this coordinate system and we have P point, let's take this point P here. Okay, this is a point P. Okay, and when you draw the perpendicular from P, we drop a perpendicular from P on the line x-axis. Okay, so PM, let it is PM, and then drop the perpendicular from P on y-axis. Okay, so this will come at point, let's say that this is point 4, not above, this is point 4 for our convenience, because we have not taken the exact point. So, okay, that we will see later on. So this is the perpendicular from P to the y-axis. This is suppose Pn. This is Pn, this is Pm. If you see this Pm, this is the length Pm. Length Pm is 4 on y coordinate. Okay, so the length of the directed line segment ON, ON, ON on the is called the y-axis or ordinate of the point. Okay, so you can see in two ways. From perpendicular, whenever you are dropping the perpendicular, okay, so this length is 6. This length is how much? 6. So this is the distance from y-axis, or you can say distance on x-axis. So distance on y-axis is called its x-coordinate, and this distance, if you see on y-axis, or distance from x-axis, this is 4. So this is called y-coordinate. So y-coordinate, x-coordinate. So x-coordinate is which distance, we can say OM. So here OM is x-coordinate. So x-coordinate is a distance from y-axis. X-coordinate is a distance of a point from y-axis. It is also called abscissa. X-coordinate, or we can also call it as abscissa of a point, abscissa of point P, this point P, that is x-coordinate. And x-coordinate is a distance. X-coordinate or abscissa is the distance from y-axis. This is what x-coordinate is the. So we can say that x-coordinate is the distance from y-axis. X-coordinate is a distance of a given point, here P, given point from y-axis, from y-axis. So there are two things you can see from y-axis, or you can see on x-axis. Or I used to say one line I am going to add here, or on, but this is from my side only, on x-axis. Means if you drop a perpendicular, you can see the distance on x-axis, that is x-coordinate. Same thing. So OM is the x-coordinate. Similarly, ON, the distance ON is called y-coordinate. Y-coordinate. It is called y-coordinate, or its another name is ordinate. It is also called ordinate. Only ordinate is written, you can understand that this they are talking about y-coordinate. And this distance y-coordinate is the distance from x-axis. So y-coordinate is what? Y-coordinate is the distance from distance from distance of a given point, P from x-axis. Okay. Now as we can, so this is called, this above system is called rectangular Cartesian coordinate system. Okay. An ordered pair with every point in a plane, the above system of coordinate with an ordered pair. So this P is always represented by the ordered pair. First is x-axis, second is y-axis. So this is called ordered pair, because order matters here. Ordered pair, first coordinate is always x-coordinate, which is on x-axis. So ordered pair, that's why it is called ordered pair. So the system with ordered pair with every point in a plane is called rectangular Cartesian system. And this whole system is called, this system is said to be rectangular coordinate system, rectangular Cartesian system, rectangular coordinate or Cartesian system, rectangular rectangular Cartesian coordinate both you can write rectangular Cartesian system sometimes we said, but it is rectangular Cartesian coordinate system, or we say Cartesian coordinate system. So as you have seen this, these two lines are dividing into two parts, four parts, sorry. So four parts. So first part, this is the first part, X, O, Y, this part. You can see this part, this first part is called first quadrant. This is called first quadrant. This whole part is called what? First quadrant. This is called first quadrant. And this part where this part, if the point lies, we say that this is called second quadrant, and this is called third quadrant, and this is called fourth quadrant. So the quadrant. How will you find where this point lies? So in this quadrant, if x coordinate both and y coordinate both will be positive because this is coming on right side and above the line. So in first quadrant, x and y both coordinates are positive. And when you go left side, this becomes negative. So x-axis will become negative, y-axis is positive. Then it is in the second quadrant. If both are negative, x coordinate is negative, y coordinate is also negative, then it is called third quadrant. And if x will become positive and y will become negative, it is called fourth quadrant. Okay. For example, as we have seen, P is a 0.64. So if both are positive, so we can write directly lies in first quadrant because both are positive. So it will lie in first quadrant. It is lying in the first quadrant. And if it will become, suppose Q is another point, which is -6 and 4. Okay, so first is negative. So this will lie in the second quadrant. This is second quadrant. And if R is a point whose coordinates are both negative, -6, -4, then it will lie in the third quadrant. And if there is a point S whose coordinates are 6, -4, then it will lie in the fourth quadrant. So by seeing their sign, positive, negative, we can find out that where they lie. Okay. And the x-axis, if a point lies on x-axis, then its y coordinate will be 0. So if a point lies on, one more thing you should write, if a point lies on x-axis, then its y coordinate is 0. Then its y coordinate is y coordinate will be 0. And vice versa. If a point lies on y-axis, then its x coordinate will be 0. So any point on x-axis, so we can say any point on x-axis is any point. If we have to write any point on x-axis, this will be P on x-axis, x0, y coordinate is 0. Similarly, any point on y-axis can be written as any point on y-axis can be written as 0y. So if x coordinate is 0, it will lie on y-axis. If y coordinate is 0, it will lie on y-axis. Okay. So this is called the Cartesian coordinate system. So our whole chapter is based on this Cartesian coordinate system. Okay. So first we have distance formula. How to find in this coordinate system the distance between 2 points. So first formula that we have, distance formula. Yeah, that means we have to find the distance between 2 points. Distance between 2 points. We can easily understand and prove this formula also. Suppose this is x-axis, y-axis, and we have to find the distance between 2 points whose coordinates has given. So suppose this is a point P whose coordinates are x1 and y1. Coordinates are x1 and y1. Another point is here Q whose coordinates are x2 and y2. So the let P and so the distance between the formula I am just writing directly for formula, then I will tell you how it comes. Distance between these 2 points, the distance between 2 points P whose coordinates are x1, y1 and Q whose coordinates are x2, y2 is given by PQ is equal to under root, this distance will be x2 minus x1 minus x1 whole square plus y2 minus y1 whole square. Y2 minus y1 whole square. So if you see this diagram, you can see that you have to find the distance between P and Q. Okay. So as you know, if you make this triangle, a right angle triangle, means you will drop a perpendicular here and here another perpendicular, and this is the right angle triangle. Correct. So what will be the distance of this one and this one? So as you know that this distance, it is on, this distance means P, if we take, okay, number L, this is L. Suppose this is L and this is M and this is N. Okay. So then what will be the distance of, means Q to M? If you drop a perpendicular Q to M, this is Y coordinate. Correct. From here, this is what, y2. This distance is y2. Similarly, this distance is y1. If you want to find qn, this will be equal to y2 minus y1. This qn distance will be y2. This is also y1. This is also y1. So y2 minus y1. This distance will be y2 minus y1. You don't have the proof, but still I am telling you how to prove it. Similarly, here, when you drop the perpendicular on x-axis from these 2 points, this is on x-axis, perpendicular from on x-axis and perpendicular on x-axis. These two distances are x1 and this distance is x1 this OL distance is x1 and this whole distance is x2, and this is also till here it is also x2. So this distance will be x2 minus x1. So this distance you will get x2 minus x1. That means we got in right angle triangle. In right triangle PQN, PQ we have to find out. PN we got the distance PN as x2 minus x1, and QN also we got the distance QN is also y2 minus y1. By Pythagoras theorem, this is the right angle, so we can use the Pythagoras theorem. So by Pythagoras theorem, hypotenuse square means PQ square is equal to base square PN square plus QN square. So substituting the value. So therefore PQ will be equal to PQ square will be equal to PN. PN is what? X2 minus x1 whole square plus y2 minus y1 whole square. And this square root will come on the right hand side. So we got the distance formula x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So this is the proof, but we are not going to do the proof. So like this, we can find the distance between the 2 points. The simple type of question we can take that find the distance between find the distance between the point. Between the point. Okay, first question we are taking point P, easy drive minus 6, 7 and Q minus 1 and 5. Minus 5. Minus 1 and minus 1 and minus 5. So here you can write the starting, it is easy for you. X1 is equal to minus 1 and Y1 is equal to 7. Here X2 is equal to minus 1 and Y2 is equal to minus 5. X1 is equal to minus 6, Y1 is equal to 7. The distance PQ, the formula for distance is PQ is equal to the root x2 minus x1 the whole square plus y2 minus y1 whole square. Substituting. So on substitution, we get x2. What is x2? X2 is minus 1. Then minus again. So minus 6 whole square. Okay. Then plus you have y2. What is y2? Y2 is minus 5 minus y1 is 7 minus 7 whole square. Just solve it. So minus minus plus, this will become plus 6. So you this will become minus 1 plus 6 whole square, and minus 7 minus 5 will become minus 12 whole square. So 6 minus 1 5. It will become 5 square plus minus 12 square. So because of square, negative and positive both will give you the positive value. Therefore, it will become 25 and square of 12 is 144 and this will be equal to 169 and 169 is the root of 13. So 13 units is the distance between these 2 points. Okay. So sometimes we have to use algebraic formulas. hmm. Sometimes they are giving to prove also, like one more question I will take in which we can have some formulas, then we can get the answers. Or A is a point whose coordinates are a t1 square and 2a t1, and B is a point whose coordinates are a t2 square and 2a t2. Yes, 2a t2, t1, t2 are variables. So find the distance between these 2 points. So as you know, x1, y1 you can write, and then can substitute in the formula AB x2 minus x1. So x2 is a t2 whole square. A t2 square minus a t1 square the whole square. X2 minus x1 plus y2 minus y1. 2a t2 minus 2a t1 the whole square. Okay. Then you can take the common a. It will become a square, and this will be t2 square minus t1 square can be written as t2 minus t1 plus t2 minus t2 plus t1, t2 minus t1. A square minus b square formula I have used, and then put a square. And similarly here 2a, when you take common, this will become 4a square, and this will remain as t2 minus t1 whole square. Now you can take it out common, a square and t2 minus t1 whole square will be taken. This is coming common. Inside the square root, if you take it out common, here you see in these two terms a square and t2 minus t1 whole square. This is common. You will take it out common. You are left in the second bracket with t2 plus t1 whole square plus this a square we have taken common, t2 minus t1 whole square taken common. Only 4 is left here. Okay, so these both are square, so we can put the square root on it. So it will cancel, the square and square root cancel. We will get the answer a t2 minus t1 the root t2 plus t1 whole square plus 4. Okay, so now we have seen the distance formula, and now we can do the exercise. The first type of question I have done it already, that the distance, you can see the distance between the points that we have done. Okay, so find the distance between the point, and can you now find the distance between the two towns discussed in section 7.2. 7.2. Okay, that is also you can try distance between the point. You can see the section, and again the coordinate can find out, and you can use the formula under root x2 minus x1. The main thing, this is very important question. There we have to prove that the points are collinear. Whether the points are collinear and are collinear or not collinear by using this distance formula. There are many ways. You will also study other ways to find the points are collinear. But what are collinear points? Uh, collinear points. The points which lie on a line. Suppose this is a line, okay? Then this line will have the point 3 points. Suppose this is a point P, P, here P, Q and R. P, Q and R all lies on the point line, then these are called collinear points. The points lie in a line. The same line. Are called collinear points. So see, by distance formula how we can prove that these are collinear points. If you see the collinearity, so if we have given these 3 points, let's say that this is P 1 5, Q is 2 3 and R is -2 and -11. Okay, then we have to prove that these are lying on a on a line. So in the line, if they are lying in the same line, so their distance between the 2 points. Now there are three possibilities. Q, we don't know where the Q, whether the Q is between P and R or R is between P and Q. Although we can find out from the first x coordinate, we can find out. So the x coordinate 1 and greater than 1 is 2 and less than this will be -2. So P should be in between and Q and R. But it is not compulsory to find out this one. But that means if Q is in between the 2 points, then in this case the distance of PR will be equal to PQ plus QR. Okay. If the sum of the two distances is equal to the third distance, then we can say that the points are collinear. If R is between, suppose, P and Q, so in this case you will get PQ is equal to PR plus RQ. And if P is in between the Q and R, then you will get QR is equal to QP plus PR. So don't have to worry about which point lying between. You should find the distance. The maximum distance will be the sum of the smaller distance. Highest value will have the sum of the two lower values than that. So we can find the distance. First we have to find the distance between the points PQ. First point PQ, x2 minus x1 means 2 minus 1 whole square plus 3 minus 5 whole square. So 2 minus 1 is 1, 1 square is 1. 3 minus 5 is 2, square of 2 is 4, 4 plus 1 under root 5. PQ is under root 5. Then find QR, minus 2 x2 minus x1 minus 1 whole square plus minus 11 minus 3 whole square. Okay, then minus 2 minus 2 4, square of 4 is 16, 11 minus 3 14. So square of 14 is 196, 196. So you get 6 plus 6 12, carry 1 9 10 11 212, correct? And find out the value of PR also. So PR is equal to PR means minus 2 minus 1 whole square plus minus 11 minus 5 whole square. So minus 2 minus 1, 3. square of 3 is 9. Minus 11 minus minus 16. Minus 16 square of 16 is 256. So 256 plus 9 is 265 under root 265. You can see which is the highest value. This is the highest value. If it is equal to the sum of these two values, then they are collinear. If it is not equal, then they are not collinear points. Okay. You have to check. Now you have to check by adding these two. If you can add them, if it is not, you cannot add them, then it is not equal to the sum of the two values. Okay. Got it? We have to check, but what you have to check is okay. So here obviously if you see the highest value, how will you check? This is the highest value PR. PR is equal to what? Under root 265, which is not a perfect square. And this sum of these two values, if you are getting PQ plus QR, PQ is under root 5 and QR is under root 212, that is also cannot be solved, so it cannot be equal. Therefore, PR cannot be equal to the sum of PQ plus QR, which implies that P, Q, R are not collinear. Okay, so there is a huge application of the distance formula. Check whether the following are isosceles triangles. Isosceles triangle. What is isosceles triangle? In which the two sides are equal. So we can take A, B, C, anyone A. A is first. Let A 5 minus 2, B 6 4, and C 7 minus 2 be the vertices of a triangle ABC. Now we have to show that this triangle will have two sides equal, then it will be isosceles triangle. So we will find the sides AB, BC and CA. If you get two sides equal, then no need to find the third side. So first we will find, okay, side AB. AB. This is just like this AB and C. ABC is a triangle. And we have to find AB, BC and AC. If two sides will come equal, then it will become an isosceles triangle. So we are finding AB. The length of the side AB means 6 minus 5 whole square plus 4 and minus minus plus 2 whole square. 6 minus 5, 1. Square is 1. 4 plus 2, 6. Square of 6 is 36. So we are getting under root 37. Then find BC. BC. Okay, this is C point. Whose coordinates are 7 minus 2. So 7 minus 6 whole square plus minus 2 minus 4 x2 minus x1 y2 minus y1 whole square. 7 minus 6 1 square minus 2 minus 4 minus 6 square of minus 6 is 36. So we got 37. So no need to find the third side. As we have seen, two sides are equal. It is an isosceles triangle, which implies that AB is equal to BC and proved, and ABC is an isosceles triangle. Okay, so it is proved that it is an isosceles triangle. So like this, you have to prove square, some other figures will be given. You have to prove that whether they are rectangle, whether they are right angle triangle, whether they are rhombus, and many questions we will take. Then in our textbook we have given this one. I will show you here only how to do this one. These points we have given point B. A, B, C, D are four friends. Okay. Champa Chameli walk into the class and after observing for a few minutes, Champa asked Chameli, don't think that ABCD is a square. Chameli disagree. Ah, अब we have to prove that whether they are sitting in a square or not. Hmm. So we have to simply find the values A, B, B, C, C, D, and A, B, B, C, C, D, and D. So what are the coordinates of B? If you drop here, this is 6. So 6 and 7. B coordinates of 6, 7. A first I will write the coordinates of A are 2 and 4. 2, 4. So coordinates of A are 2, 4. Coordinates of point B is 6, 7. Coordinates of C is 9 and 4. On x-axis 9, y-axis 4. So 9, 4, and B 6 and 1. 6 and 1. We have to prove that we have to find out whether they are sitting in a square or not. So we will find all the values A, B, B, C, C, D, D, A. All are equal, then it is a square. So first find out A, B, x2 minus x1. 6 minus 2 whole square plus 7 minus 4 whole square. 6 minus 2 means 4. Square of 4 is 16. 7 minus 4, 3 square of 3 is 9. 16 plus 9 is 25. Square of 25 is 5. Okay. Then find BC. BC, that means 9 minus 6 whole square, x2 minus x1 plus y2 minus y1, 4 minus 7 whole square. So 9 minus 6, 3 square of 3 is 9, and 4 minus 7, 3. So again 9. 9 plus 9, 18. So under root 18 or 9 2s are 18. You can also write 2 into 9. And when you put a square root, it will become 3 root 2. So obviously these two sides are not equal. We have here only that these two sides, but there is a problem. One thing I have to check. I have done something wrong. 6 AB 6 6 minus A. What are the coordinates? Oh, sorry. A coordinate I have written wrong. That's why this is 3. Here also this is 3 actually. That's why we were not getting that. So 3, 3, 4. The coordinates of A are 3 and 4, not 2. So 3, 4. So now you get 3 here. Okay. So 6 minus 3. 3 square of 3 is 9. 7 minus 4, 3 square of 3 is 9. Under root 9 plus 9, 18. And 18 can be written as 3 root 2. A, B, B, C. A, B, B, C, C, D. B to D. Means 6 minus 9 whole square plus 1 minus 4 whole square. 6 minus 9, 3. Square of 3 is 9. Here also 9. Under root 9 plus 9, 18. 2 9 is 18. 3 root 2 again. Okay, then DA. Similarly, D to A. 6 minus 3, 3 square 9. 1 minus 4, 3 square 9 plus 9, 3 root 2. So all are equal. All are equal. A, B, B, C, C, D. All sides are equal. But it cannot be a square. It can be a rhombus. So we have to check diagonals also. You cannot say square because it can be a rhombus. All sides are equal in rhombus. But diagonals are not equal. So if diagonals are equal, then ABCD is a square. If diagonals are not equal, then it is a rhombus. So we have to check the diagonal means. Which are the diagonals here? You can see this is the AC. AC is a diagonal. AC, A to C is the diagonal. One diagonal. Another diagonal is this one. Okay. So we have to find the diagonal also. So AC here I will do it. AC diagonal AC is equal to what? 9 minus 3. 9 minus 3 6 square plus 4 minus 4 0 square. 6 square means 6. Similarly, BD diagonal BD is equal to 6 minus 6 0 plus 1 minus 7 6 square is 36. The root of 36 is 6. So we got AB and BD. AC and BD. So AC is equal to BD. Diagonals are equal also. So therefore, sides are equal. 4 sides are equal and the diagonals are also equal. And the diagonals are also equal. Okay. Therefore, A, B, C, D is a square. Hence, Champa is correct. Champa said what? It is there sitting. Champa walked and observing. Champa asked, don't you think ABCD is a square? Okay. So, Chameli disagrees. So, Champa said is square. So, therefore, Champa is correct. Hence, Champa is correct. Okay. So, like this now, next time we will have many questions on quadrilaterals, reasons here, and some other type of questions, extra questions also will be taken and we will complete this part, then section formula will be started. Okay. So that's all for today.